Yeah, so I'm Brian Richter. I'm right now the DevOps engineer for the Haskell Foundation, which means I work on the CI pipeline for GHC mainly. I like doing automation for GHC development. It's been really fun. And for this talk, I wanted to talk about like how Haskell gets delivered, how features in the Haskell language actually get to users. And I was going to do that by talking through like the GHC value chain. And then I thought, actually, maybe I'll talk about what is this value chain thing. There's a bunch of steps that I'm basically going to walk through that I think are important when it comes to delivering value to through software. So to talk about that, I should talk about what do I mean by value in the first place. Basically anything that makes the world a better place, or something that makes you money, if that's what you're interested in, or both. If you can do that, that's pretty cool. It's not something that you have to do. You don't have to be into that. But if you are looking to do that, if you are looking to create value for people with software, then I think these are some things to think about that can be useful and valuable. I am going to, as I said, talk through how GHC does this as a kind of a running example as I'm talking about the different steps. So just some quick facts about GHC that will play into some of the things I talk about later. It's been around for a long time. It's 30 years old, a little more than 30 years old. It's written in Haskell. Hooray. That means it's a bootstrapping compiler, so you have to have a GHC in order to run a GHC, I guess. We just talked about that. Which has pros and cons. It is maintained by a full-time team of about 6 people who are paid to maintain it and work with contributors. And then there's a rotating cast of maybe a couple dozen more regular contributors who are involved. And it's also interesting the way that GHC is funded. It doesn't have so much of an impact, but I mean it does a little bit because we're talking about users and value. Part of the funding for the GHC maintainers comes from sponsorships or donations. So people are actually paid just to maintain it and to work with the community to help contributors get their patches into GHC. And then some of it actually is paid by individual clients who want individual features real bad. They have some feature they want either in the compiler or in the language, and they will sponsor development. Let's see what I talk about next here. Okay, so yeah, I'm just jumping in here now. The first step of this value chain is identifying what the value is. I'm going to just make a little change here. And really what that comes down to is talking to people. I can't stress that enough, that if you want to create value for people, you need to know who those people are, and you need to know what they want, and that comes through talking to them, having relationships with the people who are going to be using the stuff that you have. In the example of GHC, the users are us, or you, people who use Haskell, because what GHC is providing is the Haskell language. And I wanted to talk about briefly, there's these 2 committees to help with value identification. In the case of GHC, this old compiler with a mature language that's used in all kinds of places. It's really hard for one individual to know all of the consequences of some change you might want in the language. And these 2 committees are there as storehouses of expertise to help you make sure, or to help a contributor make their changes as good as it could be. The GHC steering committee is focused on the language itself and the compiler. It's kind of, there used to be a Haskell language committee, and now this is more like the predecessor to that, or the one that comes after. And then there's the core libraries committee, which is for the base libraries that are usually often really closely related to GHC. Sometimes changes will affect one or the other or both. But the point is that for GHC, the users are Haskellers, and the value provided is the Haskell language, and changes kind of are helped through by these two committees. I think the next thing I'm going to talk about is like the next step here. I think that a little bit of project management is always valuable. The key is that you need very, very, very little of it. You want to know, like, what am I doing? You want to keep track of, I think, what are you doing and why are you doing it? Because it's really easy to like have an emergency come up and you have to work on something else for a while, or you just don't have time for your side project for a little while, or whatever, you want to work on something else. And it's nice to be able to quickly get back into what you're doing. So I think a little bit of management is important. But like, honestly, start with a pen and a physical piece of paper and just write down to-do notes, because otherwise you'll like go into a rabbit hole and spend 5 years of your life coming up with the perfect project management system, and in the meanwhile, you won't be delivering any value. So keep it simple, but I think a little bit is useful. In the GHC example, they use GitLab. It has all of this stuff they're trying to, have tooling for the entire life cycle of software. And so the issue tracker is really where GHC HQ manages all of its stuff. They keep track of new features. They keep track of bugs. This is examples from the release that's coming, the 9.8 release that will be released soon. And that's just the place to go for all that stuff. And it's also, incidentally, the best place to get in touch with GHC maintainers is on the issue tracker. The next step is the fun step, actually doing the coding. And I'm not going to talk about that so much for this particular talk. We'll talk about that a lot in other settings for Haskell. Haskell is fun. We use Haskell because it's fun to code in Haskell. I think what's important to remember is that it's just one small step of the puzzle if you're trying to deliver value to someone. In fact, it's a very small step. Well, I wouldn't say it's a very small step, but it's a small step, and it's important to focus on the other things as well. Did I want to say something else about that? I don't think I did. Example of GHC, it's just Haskell. It has lots of good code comments. Yeah, whatever, you don't need to get into it really. Now, you can't really talk about writing software without talking about writing tests. There's the joke that Haskellers say, oh, I don't need tests because type system, category theory. But I think we all know that's not true. We all really appreciate tests. Every Haskeller I've ever talked to thinks tests are worthwhile. The software testing in GHC, there's a lot of tests in GHC. The thing about testing in GHC is that we have all these nice libraries to use in the Haskell ecosystem, but GHC can't really use them because of the bootstrapping compiler nature. Like, you need to minimize the footprint of the dependencies that you have, because you need GHC to compile the libraries. If you need the libraries to compile GHC, it's really easy to get stuck somewhere where you can't even build what you're trying to test anymore. So it has a really small footprint, but it does have lots and lots of tests. And most of them are what are called golden tests, where you have some input, you run some process, and you expect the output to look a certain way. And GHC is a compiler, so most of the input is Haskell programs, small little Haskell files that exercise some feature of the language or some feature of the compiler, and the test runner runs GHC on that program and compares the result to some expected result. It could compare like performance, how much memory does GHC use, or like does it actually compile still, or does it not compile? And you can also run the program. Is the program performant? Does it put the output you expect it to put? So heavy use of these golden tests. Now, I think this is the crux of the whole thing. The step after you have your software, you've well, you've identified what value you want to create. Well, you know who your users are. You write the software. Great, you're done, right? No, that's the classic mistake. And to tie this back into DevOps, I think that's the mistake that sort of drove the creation of DevOps as a concept, because it was too easy for people to focus on building the software and then what? And in the past, what would happen is you would throw your software over a wall and hope that somebody picks it up and gets it into the hands of the users. And it's like, if your users aren't actually using this value you've created, you haven't created any value. You can have the best code in the world, it's tested, it does exactly what they want, but if they're not using it, there's no value being delivered. So actually putting the software into the hands of users, giving them the features that they want, the behavior that they want, is the important key. So delivery is super important. I can go on and I will go on. The first principle of the Agile Manifesto is our highest priority is to satisfy the customer through early and continuous delivery of valuable software. The focus is on delivery. I mean, the valuable software, you could even, I don't know, yeah, that too, I guess, but delivery of the software is what has to happen. I'm going to talk about this a couple other ways. You have to let people know it exists. You don't have to, be a salesperson, but just even having a small group of friends or a community you can work with or share things with is important. Ideally, like I said at the beginning, you know who your users are and you're talking to them, so you can at least let them know that it's available now. Hey, check it out. GHC, I think, does a pretty good job of this. They've got a ton of different outlets that they post their when there's a new release that comes out. Another important one about delivery is it's not always enough to give the people what they want, but you also have to think about the context of what you're giving them and how they're going to use it. It might, if there's conflict with, I'll just go to the GHC example. If you create a new language feature that's great and everyone wants it, but it's incompatible with some base library that everyone needs to use as well, then have you really delivered any value? Because now people are stuck waiting for changes to percolate through the ecosystem. Maybe there's a dependency chain of 5 or 6 things, and if it takes a month for each person to realize, wake up, accept the pull request, go back to sleep, it's going to take a while to actually get the value. So you have to think about not just the thing you're delivering, but the context in which it's going to be used. Continuing with delivery, I was thinking of this in the GHC terms, GHC creates bin lists, or the GHC HQ. These binary distributions, they're basically tarballs that they put on a website or an FTP site, and you can download them and run them and blah, blah, blah. Not too many people do that anymore. Instead, people are using GHC up or stack to fetch GHCs for them. So now you have this channel. You have a distribution channel for your software. And, the analogy here is if you're creating potatoes and you've got a deal with the S group to sell your potatoes in their stores, if the stores go away, nobody gets your potatoes. You need to keep that in mind as well, that how people get your software is if you need to you can't own it because it's somebody else's work, but you have to be responsible for it. You have to be reactive to changes, and now you have to maybe have relationships with the people in the steps of the chain that get to the users as well. I think GHC up is a good example of this, doing this really well. GHC has evolved a lot. They're starting with these bin lists, which you have to download and run some commands. You have to use sudo make install or whatever. And nowadays, as soon as a new version of GHC is released, GHC up will just automatically fetch new metadata and know about it. So you go, oh, cool, I see the blog post, there's a new GHC. You just go to GHC up, don't need to, it'll automatically update itself and you'll just be able to select it from the list. So that's an example of, having good interaction with the channels that people use. I've talked about these things already, I guess. What's stack? Stack. Is it? I am sort of assuming a general familiarity with Haskell. I think most people have probably heard of stack. If you haven't, stack and cabal are two alternative ways of managing packages. And I haven't talked about packages either. But I guess all of that is important in the context of GHC delivering value. There's this hierarchy of, I don't know if hierarchy is the right word, a pyramid of components that fit together to build software. We all know building software is complex, and so there's lots of ways of abstracting over the complexity. Stack and cabal are here's GHC, and then stack and cabal are a little bit higher, and then you've got everything else above that. Part of the value chain. So we're getting to the end now. Step 6 of the value chain is feedback. And if you remember at the beginning, I said it's really important to talk to users. That's part of how you get your inspiration for what is it you're going to create? What value are you creating for people anyways? And well, that's also the last step. Now that you have hopefully gotten value, gotten useful things into the hands of users, you need to learn from them what is how it's going, what's new. Because as humans, we inspire each other, and I don't think you can come up with the best thing in a vacuum. You have to put something out there, hear what the feedback is, and go, okay, that gives me a new idea. I can make it better by doing this, that, and the other thing. So really, it is a loop. New inspiration leads to new features, leads to the cycle starting over again, and so on. And this is, the DevOps is all about cycles, and Agile is all about cycles, and this is what I think that's about. Maybe something that's often dropped in standard DevOps discussions is that the cycle isn't just you sprint and you write some software and then you sprint and you write some software. The cycle is getting some feedback from a user and feeding that back into what is it that we're actually doing. And then there's a bonus step. And I'm really proud of this. You want to run that loop as often as possible. You want to get feedback out as quick as possible. You want to feed it back into the system. You want to come up with something newer, better, different, and go through the cycle again. And one way to, automation is a force multiplier for that. If you create more value by getting through the loop as often as possible, then by automating parts of it, you can generate more value. So in particular, the testing and delivery phases, that's where CI often comes into the picture, continuous integration, continuous delivery. I would love to talk about those more another time, or I don't know how I'm doing on time here, if there's questions now. Yeah, I think I have, we're gonna have lots of time for pizza, so happy to talk about things more later. And that was it that I had there. So thank you. Yes, question.
Yeah, question. So that's an overview.
Yes.
But you're embedded in this process.
Indeed, yeah.
You must have super interesting insights on what are the next things to improve or work on, or?
Yeah, I have some ideas. I could talk,
What works very well? More you have more or can you talk about more concrete examples or illustrate with that?
To start with, like, this is the part that I'm working on, the automation part. The test suite, like I said, JC has a lot of tests, they're great. The test suite itself is also really old. Well, really old. It's mature. It's older than any of the CI steps, like the CI infrastructure that was created now to run the tests automatically. And the breadth of platforms that we can run the tests on is much greater than any one person had in the past who was developing the test suite. So nowadays, there's these thousands and thousands of tests, and a bunch of them just don't work on certain architectures or work part of the time on some architectures, and you're not really sure why, and no one's had the time to look at it yet. So there's this whole, in the test suite, there's this whole framework for marking tests as fragile and then ignoring their results, which is like, oh God, it's had to be done that way. It's practical. You have to first contain the problem, and then you can solve the problem. So like that is future work. Like the problem is fairly well contained now. Now it needs to start being solved. Having more platforms is really useful for that. You find edge cases in the compiler. Like some of these tests are totally fine on the architectures that people have mostly developed GC on, but then you go somewhere else that is exotic and it doesn't work anymore. Isto?
Okay, in the beginning you said, or there was that about 6 people is working with the GHC development at the moment. And, are they from the different companies or academia or?
Yeah, good question.
And so what kind of people they are?
There is, I would say the core maintainer team is mostly at well-typed. Because well-typed has they're the ones who have the contract to do GHC maintenance, to support the community by working with people on their pull requests or their merge requests and making releases. Making releases is a lot of work. So that's well-typed. And that's where most of the around 6 people come from. And then you still have Simon Peyton-Jones, who's really active, very active on and who's he working for now? He's working on Verse for whatever that company's called. I forget. Oh, yeah, thank you. Nonetheless, he still works on Haskell quite a lot, and there are people at IOG who work on the compiler a lot, and Tweag also has a fair number of GHC developers. So a mix of, definitely a mix. Martin, you had another question?
Oh, I have 2.
Oh, fantastic.
Maybe let's start with the closest related to new architectures. Sorry, Alex, if I'm talking a bit in your name, but you might be interested in asking that. How would Alex be able to write a new test to highlight the segfault he's having so that it never happens again in GHC? Or is that the right place for it?
There are ways of, like the test infrastructure that exists definitely has ways of writing tests for specific architectures. You can disable them for everything except a certain architecture. So then you would just write the test that you like. If you have something that causes a segfault and then you fix it so it doesn't segfault anymore, you can keep the test as a regression test. What?
Are you actually running these tests on different architectures? So let's say you have your RISC-V segmentation fault that is being tested. Will the test actually be executed on RISC-V?
Yes, I think that GHC has a platform support policy. And I think to tie this into what I'm talking about, and to tie it into DevOps. DevOps is usually talked about in the in the context of continuous services, like you're running a web app or a web service, and DevOps is thought about in those terms. GHC is not that, you know, it's delivered once a quarter as a binary file on an FTP site. But the same sort of things apply. But one thing that makes GHC hard is like you have to support all these platforms. And it can be a real mess if you don't have some sort of policy deciding like, okay, which platforms do we create bin dists for? And the rule is now actually that you have to have CI runners for the platform and create bin dists on those runners in order to like have bin dists created. So it's not so much like are there runners, but if you want RISC-V to be officially released, then there have to be runners. And one of the platform tiers is that the community has provided a runner, and if you know you can keep it up and running. I think that maybe needs to change a little bit because it's a little too gray zone. Like, okay, great, like version 9.x supports it, or let's say 9.8, let's say 9.10 has RISC-V, and then you know life happens, and we've got one person with one RISC-V available, and then they're not available anymore. You know, does 9.10.2 drop RISC-V as a minor release? Like that would suck. So I think that we would need to figure out how to have a reliable pool of RISC-V machines to make that happen.
I think we have time for one more question.
It's all you, Martin.
I'll pull one from us.
Oh, you still almost had one.
But this is not so serious. But okay, so if you could fix one thing, say on your daily job that you are facing there, what would be it?
Honestly, it would be to have a single pool of multi-platform machines that I could actually SSH into all of them, because right now, because there's like community supplied stuff, I don't even have access to everything. So a pool with centralized access of reliable runners for all the platforms that are supported. That's what I wish I had.
Great, we know how to help now.
Yeah. So the Haskell Foundation is very happy to accept new sponsors. I'll do the work of setting it all up. We just need to, and we honestly, that's actually going to be one of the things I work on pretty soon, is setting that up, because we do have the resources for that. We just need somebody with the time, and that's me.
Cool. All right, thank you, Brian, for the nice talk.
Thank you.